Every serious take on training a language model assumes the same starting point, a GPU cluster, or at minimum, a rented A100 sitting somewhere in a data center on somebody's cloud bill. I never had that. Every phase of aarambh-studio across all three major versions, all the way through the version 3 attention rewrite, was trained entirely on free GPU notebooks on Kaggle. And before you assume where this is going, this isn't a video about a shortcut to free trained weights you can download. I don't release trained weights at all, on purpose, and I'm going to explain exactly why later in this video because that decision is directly tied to the compute story. This is the honest version of what training on free compute actually costs you, why I chose it anyway, and where I genuinely tell you to pay for cloud instead.
Before we dive in, I want to talk about Aarambhic Dev Hub's partner, Codecrafters, and this one I actually mean it when I say it is a good one. If you have been watching Aarambhic Dev Hub for a while, you already know that we are all about understanding how things actually work under the hood. Not just using tools, but truly understanding them. Why does Redis work the way it does? How does Git actually store your commits? What is really happening when you type a command in your shell? Codecrafters is built around exactly that same curiosity. Codecrafters is a platform where you rebuild real developer tools from scratch. Things like Git, Redis, a shell, an HTTP server, a DNS server, a BitTorrent client, you actually build them yourself, stage by stage, in your own language. Every stage unlocks the next, and you can see exactly how far along you are as you go. Now the most popular language on Codecrafters is Rust, and that makes total sense for this channel. If you're just getting started with Rust and want to learn it the right way, this is honestly one of the best approaches out there. Instead of reading theory or doing small exercises that go nowhere, you sit down and build something real. Something you have actually heard of. Something that exists in the real world. And that is when Rust really starts to click. This is not your typical tutorial platform where you just watch someone else code and feel like you learned something. You are the one writing the code, you are the one debugging it, you are the one making it pass each stage. That kind of active, hands-on learning is what actually makes you a better systems programmer, and I will be honest. It is genuinely a lot of fun. The challenges are used by engineers at companies like Google, Meta, and Shopify. And if your company has a learning and development budget, there is a very good chance Codecrafters is covered under it, meaning it could cost you absolutely nothing out of pocket. Worth checking with your manager before you pay yourself. The link is in the description below. Check it out, and if you do sign up through it, you also directly support Aarambhic Dev Hub, so thank you in advance if you do. Alright, now let us get into the video.
Most people don't think of compute as a decision at all. They think of it as a requirement. You need to train a model, so you need a GPU budget, and the only real question is how big that budget is. I wanted to actually test whether that assumption holds, or whether it's just a default nobody questions. Free here means something specific. Kaggle's free notebook environment, with either a single P100 or a dual T4 setup as the accelerator, running in timed sessions. No dedicated server, no persistent machine sitting there waiting for me, no bill at the end of the month, just a notebook I open, run, and eventually have to close, whether the job is done or not. The first reason is almost psychological, but it's real. The moment compute costs money, every experiment carries a small tax of hesitation. Is this idea worth the bill if it doesn't work? That hesitation quietly kills exploration. You stop trying the riskier architectural idea and default to the safe one, because the safe one is cheaper to be wrong about. This project was never funded work. It's a from-scratch learning project, built to understand how a language model actually works, not to hit a deadline for someone paying for GPU time. Free compute meant I could genuinely explore across 3 major versions and more than 30 phases of work, including the version 3 attention rewrite that replaced the entire attention mechanism without a running bill shaping which ideas I was willing to try. Here's the part people don't expect. Free compute isn't unconstrained. Kaggle sessions have a hard time limit, and once that clock runs out, the session ends whether your training run is finished or not. That constraint sounds like a pure downside, and in the moment it often felt like one, but it forced design decisions I'm genuinely glad I made. Every phase had to be built around checkpointing and resuming cleanly, because a run getting cut off midway wasn't an edge case, it was the default assumption. The 4 model scales this project supports, 25 million, 117 million, 360 million, and 1.3 billion parameters, aren't arbitrary. They're sized specifically so that meaningful training actually fits inside what a single free session can realistically do. And the quantization-aware training work, getting int4 and int8 export to align cleanly with the GGUF format, genuinely took longer to get right than the attention rewrite itself, precisely because getting it wrong on constrained hardware is expensive in a way it wouldn't be on a bigger machine. If this honest look at building under real constraints is useful to you, hit like. It helps this reach more people. Subscribe if you want more of this kind of deep dive. Let's keep going. Reason 3 is about who gets to follow along. If this project needed a rented GPU cluster to train, most people watching this video couldn't actually reproduce any of it. They'd be reading about the results secondhand, not running the code themselves. Because every phase runs on the same free tier anyone can sign up for, the barrier to actually trying this yourself isn't money, it's just time and curiosity. For a project whose entire point is teaching how a language model works from the ground up, that accessibility isn't a nice-to-have, it's the actual point. Now the part I said I'd come back to. aarambh-studio is Apache 2.0 licensed and source only. I release every line of code, but I don't distribute pre-trained weights, and that's a deliberate choice, not something I haven't gotten around to. Here's the honest reasoning. Models trained under free tier constraints, at scales chosen to fit a single session's time and memory budget, are proof of concept and learning artifacts. They're genuinely useful for validating that an architecture works, but they were never built to compete with production models trained on real clusters, and releasing them as finished, downloadable weights would imply a level of polish that isn't accurate. There's a second reason, and it connects directly back to the compute story. Because training itself costs nothing and runs entirely on infrastructure anyone can access, the source code is the actual deliverable. If you want the weights, you can train them yourself, for free, using the exact same notebooks I used, which teaches you far more than downloading a file ever would. That's the whole philosophy of this project in one decision. I want to be direct about what free actually costs, because it isn't nothing. The session time limit means checkpointing isn't optional. It's constant overhead on every single phase. There's a weekly GPU quota that resets on Kaggle's schedule, not mine. Hit that limit mid-phase, and the work simply waits, sometimes for days, no matter how close I was to finishing. There's no persistent storage between sessions either, so every checkpoint has to be explicitly saved out and reloaded, which is its own layer of engineering that a dedicated machine would never require. And even where this project did multi-GPU training back in version 2, that meant Kaggle's free dual T4 option, not a real cluster. Some experiments that would take an afternoon on rented hardware simply aren't possible at all on this budget. So here's the honest verdict. If this were funded production work with a deadline, I'd tell you to pay for cloud compute without hesitation. It's genuinely faster, and time has a cost too. I chose free Kaggle GPUs because this project's actual goal was reproducible from-scratch learning, not speed. And for that specific goal, the constraints were worth the trade. Let me put some real detail behind all of this. Every phase of aarambh-studio, across 3 major releases and more than 30 phases of work, was trained entirely on Kaggle's free T4 and P100 notebooks, including the multi-GPU work in version 2, done on Kaggle's free dual T4 configuration, not rented hardware. The project supports 4 model scales: 25 million, 117 million, 360 million, and 1.3 billion parameters. deliberately sized to fit a single free session's time and memory budget. Training data spans Wikitext 103, Alpaca 52,000, GSM 8K, and a set of roughly 2,100 synthetic examples generated for this project. And the whole thing is Apache 2.0 licensed, source only, every phase reproducible by anyone on the same free compute I used with 0 pre-trained weights distributed. If you're working on anything like this, training under real constraints, Rust, from-scratch AI, come join the Discord. Links in the description. We run a weekly study group every Sunday, and it's a genuinely good place to compare notes with people actually building, not just watching. If this project or this channel has been useful to you, the biggest way to support it is through GitHub sponsors or Buy Me a Coffee, both linked in the description. It goes directly toward the time behind projects like this one, and it genuinely helps me keep building and open sourcing this work instead of gating any of it behind a paywall. So that's the honest answer. Not free compute is just as good as paid, but 4 specific reasons this made sense for this specific project. It removed the money question from every experiment, the constraints forced better engineering than I probably would have written otherwise, it kept the whole thing reproducible for anyone watching, and it's the direct reason I don't distribute pre-trained weights. The source code is the deliverable, not a download. And the honest cost, constant checkpointing overhead, a weekly quota I don't control, no persistent storage, and some experiments that just aren't possible on this budget. If this gave you a clearer, more honest picture of what training on free Kaggle GPUs actually involves, hit like. It helps this reach more developers. Subscribe if you want more from-scratch breakdowns like this one. Drop a comment. Would you train a model on free Kaggle GPUs, or is paid cloud compute worth it for you? I read every comment. Full source is linked below if you want to reproduce any of this yourself, and I've got other videos on the wider reasoning behind this project linked in the description if you want to go deeper. Join the Discord, links below, and thanks for watching and happy coding.